Hey guys, all right, moving on with chapter 1 of science. We are into lesson 3. Remember, chapter 1 has been all about different kinds of energy, and this week we're going to be talking about what is light energy. So there are different sources of light. The sun is a very important source of light energy on Earth. Without the constant light energy from the sun, Earth would just be a dead planet because it would be too cold and too dark for anything to survive. Plants use sunlight and they change it into chemical energy, which they then turn around and use to make their own food. So if plants don't have the sunlight to make the food they need, well, then the plants would die. And without plants, animals would die off too because animals need those plants to survive. There are other light sources on Earth besides the sun, though. There are actually some animals that give off light called bioluminescence. You probably have seen fireflies or lightning bugs, whatever you want to call them. When they glow, that is called bioluminescence. Their bodies give that off. And then humans also discovered that they could create their own light when they had the discovery of fire. So that completely changed how humans lived as well, because they found out that with the discovery of fire, they could work after dark. So that was awesome. Light waves that we can actually see. You know, we've talked about sound waves and how we hear sound waves, but we can't see sound waves. Well, we can actually see light waves. So the form of light energy that we can see is called visible light, which makes sense, right? Because visible means that we can see it. Light energy travels from its source as waves, just like sound waves do. Sound waves come out of our mouths, out from an instrument, from tapping on something, and they travel as waves. Light does the same thing. It travels from its source, from the thing giving off the light, as a light wave. Like all waves, light waves also have wavelengths and frequencies. We talked about that last week with sound, how different wavelengths and different frequencies are what make sounds sound differently. White light, like you see from a lamp or from the sun, is actually a blend of the colors red, orange, yellow, green, blue, and violet. Sound familiar? Those colors make up the visible light spectrum, and they are always in the exact same order: red, orange, yellow, green, blue, violet. They will always be in that order because they are arranged by their wavelengths and their frequencies. If you didn't know why that sounded familiar, right here, that is a rainbow: red, orange, yellow, green, blue, and violet. That is the visible light spectrum, and that is why they are always in that order when you see a rainbow, because they are organized by their wavelengths and their frequencies. All right, last thing we're going to talk about today is prisms. A piece of glass called a prism separates white light into its different wavelengths, and a prism allows you to see the colors. As you move from the colors red down to blue, the wavelength decreases and the frequency increases. So remember, that wavelength is how long the wave is, and the frequency is how many there are in one cycle. And here is a prism right here. The white light comes in to the prism, and then once it hits this prism, that prism allows it to reflect off of it and bend, so it's actually refracting into each of the separate colors. So we've got red up here, which means that this is the highest wavelength and the shortest frequency. And then as we move down here, we've got the lower wavelengths and the higher frequencies. So that's pretty neat. Alrighty, we are going to stop there for today. Please make sure that you go log on to Pearson and you double check and do your assignments that you need to do, and we will pick back up with this tomorrow. Alrighty guys, I will see you then.